Hello and welcome to the Technical Director presentations. The TD course is a postgraduate course at the Institute of Animation, Film Academy Baden-Württemberg. The Technical Directors in most cases have a preliminary diploma in computer science or similar, and they tackle the technical challenges of the productions at Film Academy. That could be animated shorts or visual effects productions. We'll also see a first virtual production in the upcoming hour. If you're interested in studying, there's good news. The application deadline is 5th of May for starting in fall. And if you're from abroad, that's not a problem. We're accepting applications from worldwide. There's no tuition fee, and you don't need to have any German language skills. So if you're interested in learning more and have questions, I'll be here to answer any of your questions after the talk. So let's welcome our Technical Director students.
So, hello, my name is Yafes Sahin, and I'm a technical director as well. And before studying at the Film Academy, I was studying at the University of Applied Sciences in Salzburg. Maybe some faces are here from Salzburg. Yeah, and I studied filmmaking, and at the same time studied game development. So today I want to show you some projects where some cutting-edge real-time technologies was used for virtual production. Later on, I will go on with more CG project, which called Insomnia, where I did some procedural flower simulation. And the last one will be a research project I will talk about. So, maybe can I ask first a question, who doesn't know, or who knows what virtual production is? All right, 1, 2. So maybe I will just give a quick introduction to virtual production. So the easiest way to explain virtual production is the way how the movie Avatar was made is in virtual production. Basically, when you're filming your movie, you have the final rendered images on set. So it's in the ideal case, you will finish the movie when your last shooting day is completed. So I worked on a project called Dark Matter, made by the director Henryk Wojciechowski. It was his diploma project. It's a 3-minute short, and it will be presented tomorrow. And my task was to set up the whole pipeline, because it is a new engine. So we were using the Crytek's Cinebox engine, and we had to develop some pipelines to make it possible to use the traditional VFX tools and combine them with the real-time cutting-edge engines. So maybe I will just show behind-the-scenes movie first, and then talk a bit about the tools I have developed and the problems we had.
Du coup, ça te permet d'imaginer, et vu qu'il y a du nouveau matériel, tout ça, c'est une nouvelle technologie.
Ich merke auch, dass es den Schauspielern wirklich hilft, dass sie einfach danach sehen können, was passiert.
So, actually, when you do virtual production, you don't have one pipeline, you have 3 pipelines. You have one pipeline for the pre-production, you have a pipeline on set, and you have a pipeline for the post-production. So what I did is, before going on set, I did some small testings. I was working in a manner of test-driven development, which means that you pick some little parts from your virtual production problem, test it, you see it's working, and then you go and set. Because otherwise you will not achieve, or you will not be able to get the complexity done. So what you see here is a very complex pipeline flow, data flow. So you can see how much complexity comes into virtual production. So it's better for the art, but it's complex for the technical guys. So an abstracted version of my pipeline was this here. You can see at the top the motion capture system. The motion capture system gave us the ability to track the camera position, which was then injected to the game engine. And from the game engine, from the position of the camera, we could render an image, and this image was sent to the live keyer, which you can see here. This live keyer took the game engine image and the image from the DOP's viewfinder, made a chroma key on it, and the director got the final image on set and could do whatever he wanted with his camera. So to make this possible, I had to write several plugins and tools for the interfaces. I will show you one plugin I have created. Sorry for that. Just press and play. So what you can see is the Cinebox engine where I connected to the motion capture system, which was OptiTrack in our case. And the collected data of the camera could then be exported to Maya, which then could lively send to the Cinebox engine, which you can see here now that the motion capture data was directly used in the engine for the production and as well for the post-production. So maybe this slide will show you more how this worked on set. So you see at the left-hand side the engine, and at the right-hand side the OptiTrack motion capture system. And this data was collected on set, and on set we had a real-time preview of what's happening on set. So this was quite cool, because you see what we did here. Normally you have to match move all the shots in a VFX production, and because we had the camera tracking data, we could use it for the camera positioning, and we get rid of match moving, and we could avoid match moving for 95% of the shots. So the next topic I want to talk about is my scholarship I got from the institution called MFG Stiftung Karl Steinbruch Stipendium. It's a scholarship which you will get for innovative technologies. And from the problems I had on the virtual production project, I created a tool which you can use on set. You can just use your handheld device on set. And you see here normally we are trying to solve problems in set like this. You have a hierarchy, and the problem is not being solved well. And with a new tool, everyone will use his handheld device and can see the camera data, the real-time engine data, the chroma key data, and then can actively work on the problem. So this was a project which came from the problems I had on our virtual production project. So this is showing how it works. You have the server where all the data is collected from the engine, from the camera, and then different types of streams will be sent on the different departments, mobile handheld devices. And I have a short demonstration of it. It's the beta status. So what you see here actually is the server is sending the data to mobile phones on set, and you have a very accurate transmission rate. Normally all streaming servers are just there to send reliable data, but in my case I need fast transmission of data. So I am working currently with the Max Planck Institution, which are creating a technology called DAAS, which stands for Display as a Service, which can transmit data very fast in the protocol. So the next thing I will talk about, so we're getting now to more CG stuff. I worked on a project called Insomnia, which was a diploma project from Christian Bohm. And he needed a procedural flower, which he could use in different ways, in different shots. And therefore, I had to build a setup in Houdini. So Houdini is shipped with a system called the L system, which is a description for plants or trees. But I avoided using it as it's very unflexible. It's science for me, for itself. So what I did is I tried to describe the flowers or the leaves in the manner of phyllotaxis, which means arrangement of leaves. So, what you basically can see here is I was just generating the starting points of the leaves with an algorithm called phyllotaxis, and this was very artist-friendly, as he could change the view, and he could just take an input mesh to create the look of a flower. He could do a spline animation if he wanted, and I added secondary motion to the flower with some dynamics, so this was very cool for the artist. So here is a short demonstration how the OTL, the digital OTL for Houdini works. So you can just adjust the shape of a plant, which is just a mesh the artist has exported, and you can define motions of the flower and as well some secondary motion to give it a more natural look. This is the basic version, and in a shot it looked like this. So I want to present my latest project I'm working on. As a technical director at the Film Academy, you have to work on research projects, which you can choose by yourself. And I'm working currently with the Max Planck Institution on shape refinement. Basically, what it is, shape refinement is you shoot from the camera images and you try to get the shape, the model, the base mesh of the collected images. And this works actually quite fine, but it takes a lot of time. I won't go into detail, but I will show you a video. How much time we have? All right, here's the video. What you see here is from a motion capture system where the images were taken, we create a base mesh. What you can see at the right-hand side and left-hand side are the images we had collected. And you can use this mesh to create a shape refinement so that you have, so basically what you could do afterwards is you can take a movie with your motion capture equipment with the cameras. So it don't be to motion capture system, but only cameras. And then you can afterwards do any camera movement you want. You can go into details. You have the same flexibility like in a game engine where you could move with the camera. Yeah. So that's it from my part, and maybe the questions later on.
Yes.
Or now, or later on?
Later on.
All right. So thank you very much. These are my contact details. And now it's going on with Manuel.
Okay, hi. I am Manuel. I am a TD student who focuses mostly on lighting, shading, and rendering. And before I started at the Film Academy, I studied computer science and media at the Hochschule der Medien in Stuttgart. Here you can see the projects that I want to talk about today. First, I want to talk about rugby bugs. I guess this doesn't need too much introduction because you've all seen it quite often these days. I did lighting and shading there for some of the characters. Then I want to talk about Globosome, where I worked on 2 shots, and I also did lighting and shading for them. But I want to talk about the fracturing and scattering process for the geometry, just because I'm talking a lot about lighting and shading anyway. And at the end, Der späte Vogel, where I did lighting and shading again, and also some smoke effects. I want to start with rugby bugs. I guess I'll jump right in with some requirements that we set for the shading for the frog and the snail. I put the frog and the snail together because their shading setup is pretty similar. The requirements were, of course, a look which is as photorealistic as possible, just to get a good integration into the set. And we had a lot of subsurface scattering on them. For the frog, when he swallows the crystal, of course the crystal should shine through his belly. And yes, frogs and snails they should be slimy. Okay, here you can see a really early test that I did. That was just at the beginning, way before there was a model or something, because I just wanted to see how I can get the subsurface scattering to work and how to make it slimy. And here you can see a turntable of the final shading result. Here, one thing you can see is that there is no texture in the back of the house of the snail. It's just because it was textured for the specific shot, and you just don't see it from behind. That's just more efficient for the texturing artist. And yeah, I think the most challenging part was to get the subsurface scattering to look right, because that's just a little tricky to figure out how to tweak it. On the actual shot, I also put some special, some extra subsurface lights basically behind the snail, just to enhance the effect of subsurface scattering on certain parts of the snail. Here you can see the frog. For the frog, one thing was that, as you can see, the ball shines through the belly. So what I did first was to draw a quick mask, so I could control the subsurface scattering for the belly and the rest of the body just separately. And also another thing that was tricky for the frog was that frogs always have this kind of slimy layer on top of their skin. And that didn't work at the beginning, because we had a displacement map with pretty distinct bumps on the back, and that produced a really high frequent reflection, and it really didn't look like a separate layer. So what I did was to blur the displacement map and render a separate reflection path, and we put that on the frog in compositing. Okay, now for the bug. Of course, again, photorealistic as possible. Then we wanted to have iridescence on the shell. I'll talk about that in a second. And we wanted the crystal to shine a little bit through its horns. Here you can see some of the references we looked up for the iridescence effect. Iridescence is just the effect that a surface seems to change its color when the angle changes that you look at the surface. And the way this was done was just to use to compute the angle between the camera ray and the surface normal, and then drive a ramp with that. So I could nicely adjust the colors. And you can see the result in a second. Just on the right side, you can see a bug that I found pretty nice. It's a rendering also, but it was too cute for our bug. We wanted it to be much rougher. So the result looked like this. And you can see how the parts, the colors kind of creep over the surface, like the yellow part of the shell is always facing the camera. So that is the iridescence effect. Okay, now I'm coming to Globosome. Globosome is a full CG short by the director Sasha Gedard, and I worked on 2 of the shots. And what Sasha wanted to have was the ground to be completely covered with broken pieces of rock, and everything should look completely dead and uninviting. So what I had to do first was to create the pieces of rock and then to scatter them all over the place, basically. And the way I did the fracturing was with Houdini. I just used a simple, pretty flat box and fractured that with the tools that there are in Houdini. And Houdini gives you just really great control over the fracturing. And you can, for example, add this noise on the borders of each fracture. And once I had all these fractures, I had to scatter them on the floor. Here you can see how this looked like. in the viewport. And yeah, what I tried first was to use a normal scattering plugin, basically, or a program, basically, but it has the problem that the pieces will penetrate each other and stick through each other, and that looks weird. So what I did was to place all the pieces in the air over the ground and do a physical rigid body simulation and just drop them all on the floor, wait until they are settled, and then I could use it. And the final rendered result looked like this. Yeah, and Sasha Geddard added some smoke, some dust, and also the plant was done by Sasha Geddard. And Thomas Hartmann also added some embers flying around through the air, and this is how we achieved the final look at the end. Okay, now I'm coming to Der späte Vogel. Der späte Vogel was a live-action short movie, about 20 minutes, with some effects shots that involved a spaceship that also starts and flies away. And yeah, I will talk about the lighting process first, and then about how I did the smoke effects. We used image-based lighting. I went on the set and captured 360 degrees HDR panoramas for the image-based lighting. The setup was to use a Canon 5D with a 15mm fisheye lens, and I had this panorama attachment on a tripod, and that enables you just to turn the camera at certain angles that you can define. So you basically take one HDR image, some exposures, then you turn the camera, take the next HDR, turn the camera, and so on until you have the whole hemisphere. And I took like 5 to 7 exposures per tile. Yeah, here you can see just an example of how the exposures looked like on the left, and then those were merged to HDR images. These are right here. These are tone mapped, just for the sake of the presentation, but of course they were 32-bit HDR images. And yeah, once I had all those tiles together, I had to stitch them to one single panorama. I did that with PT GUI, which works pretty automatically and pretty nice. And yeah, then some color correction and clean painting, and that's how I got the final panorama that I could use directly for lighting, like in the next shot that I will show you now. So this was done with lit with the panorama that you've just seen. Okay, now for the smoke effects. Yeah, the requirement was basically just to keep the scale, because this was a really small capsule and not like a Prometheus or something, a gigantic spaceship. And yeah, so the spaceship starts and it produces a lot of smoke just on the ground. And yeah, I did that again with Houdini. Here you can see a screenshot. The setup was to have a smoke emitter on the ground that follows the movement of the spaceship, and I had a force on the spaceship that just puts a lot of force downwards and forces the smoke outwards. And yeah, the rendered image looked like this. You may wonder why this is in color. That was just to give the compositor a little more control for the lights, just to tweak the colors on the 3 areas. Yeah. And the final shot looked like this. Okay. Now about what I'm currently working on. I want to, it's one thing that every TD student has to do once in his studies is it's called a scientific project, where you can, for example, implement a recent paper publication. And what I chose was to implement an automatic sky model. Sky models have been around for quite a while. They are basically something where the user can choose a position for the sun and some parameters, and then the model will compute an automatic sky, and you can use that for lighting and gives you nice results for daylight or dusk conditions. And yeah, there has been a new model recently which improves the older ones, and I want to implement that, or I'm implementing it currently with the open shading language, which is a shading language by Sony, open source by Sony, and which this would help me to, so the sky model could be used in any renderer that supports open shading language, basically. Yeah, with that, I've reached the end of my presentation. Thanks for your attention, and now it's Amit's turn.
Can I have that fancy? Go ahead. Hello? Yeah. So, yeah, my name is Amit. I'm originally from Israel. I finished studying there. I come from more of an artistic and animation background. And throughout my studies of animation in Jerusalem, I came more and more familiar with the technical aspects of creating a film and what are the challenges in that department. And I was at the Film Academy as an exchange student for 1 semester, and that's where I really decided that I want to go more into the technical stuff. And I hoped coming back here, and for some reason they accepted me back, and now I'm here. And is there anybody from Israel here? That's really good for you. So what basically I like to do is I like to create tools and procedural animation to think about things that grow from themselves, or tools that help other people make their work easier or help them get their interesting ideas in some basic and easier method. And the programs I use is I work with Maya, with Softimage, which has a sad face because it's not going to stick around too much anymore. Houdini, RealFlow, and some coding languages that I also work with. And what I'm going to talk about today is mainly I'm going to talk about stuff I did for a project that's called Ein Kutenlied, which is the frog song, where I helped to create all the software side of a motion capturing system for Maya. And I will also talk about instancing and creating some hairs for that project. And at the end, I will show you and try to explain a little bit about my research project. So first, I will show you the trailer for the movie, so you will know what I'm talking about.
Jetzt 1, 2 Schritte nach links. Nein, nach links. So. 1, 2, Kader! Was sagst du dazu?
Da knabbert was an mir rum.
Du spinnst. Aber nie kannst du dich freuen.
Ich will nach Hause, es stinkt.
Was hier stinkt, ist dein Hirn. Du dämlicher Krawattenarsch.
Ich hab langsam wirklich die Schnauze voll von dir. Was bitte, was soll das denn hier bitte schön sein?
So, the director of this movie is Karim, and he's actually sitting here, and he's a very nice guy. So the idea for that movie, what they wanted to do, they wanted to create some kind of interesting way of animation. They want to have a different feeling to it. And their idea was to do that animation, to try and motion capture it with a kind of like you do with hand puppets. So a nice guy called Flo, he created the rig, and it was connected to our Arduino board. And that Arduino board transferred the values to the system, and I was in charge of analyzing that data that goes into the computer and how to spread it and make it user-friendly to work with in Maya. So now I'm going to show you a short video which tries to demonstrate how I'm using that system and how the data is coming into Maya. So the first thing you see is this is the Arduino console inside of Windows, and you can see the data flowing into the console. On the left top side, I'll just let it run. So on the left top side is actually the rig that the animator is using. That was what was created by Flo. And the data is now flowing, and here on the right side you can see the plugin I made for getting that data and creating the attributes inside of Maya. So the data is flowing into Maya and the attributes are automatically generated based on the stream. This is the user interface that the animator is using. Here I'm disconnecting the arms and the legs because I'm not using them for the demonstration. Initializing the character to fit to the hand of the animator. Here I'm creating a new take, so each animation is creates a new take, which is basically an animation curve, and each attribute gets that animation curve. Now the data is being recorded. It's a cool frog. Yeah. And you can see the keyframes at the bottom and now playing back the animation. And all that can be done in real time, and the system can work even at higher frame rates. So what was the idea behind this? What was the main challenges in this? Was to create it to really be user-friendly and that the user won't need to go deep inside the system to disconnect animation curves, connect new animation curves, change takes, blend the takes between the different attributes, and to really make it as easy as possible for the animator to work with this system. And the way it actually works inside the system is that the data is going from the Arduino. I'm getting a rough data stream from the Arduino inside a Cookie Monster node. The system is called Cookie Monster. I don't know if I told that before. And that node basically divides the stream and creates the attributes that are later connected into the character. So from that node, it goes into here it's called the pre-post node. It's a modifying node where you can rescale the values based on the character or based on the animator, how he works with the hand puppet rig. From there, those modifier data goes into a recorder node. And that's basically like a switch node. It switches between the animation curves and between the live input. And through that, the data is transferred from that directly to the character. So it switches between different takes and different inputs, and then it goes into the character. And at the end, the user has the ability to flatten down all that data and connect the needed animation curves directly into the character. So at the end process, there's no need for any of those nodes or plugins to make the animation work. The next part that I want to talk about is about this project is if you can, I don't know how good you can see it on the projector, but those leaves, they have fluffy hairs at the end of them or in the bottom. And the challenge here was that because we were using the R-Node render system, and R-Node can render curves as hairs. And first we thought that we can scatter those curves using the Maya particle system and to use the Maya instancer to then render those particles as curves. The problem with that was each time we wanted to use that, we had to simulate, resimulate, retarget the particles based on the moving meshes. So my solution to that, I created some kind of hack into the Maya instancer system, and I created a plugin that generates all that particle data, and it drives it directly into the instancer node. So we have particle data that is not coming from simulation, but we are generating ourselves, and the user can control that with texture maps and rotate the hairs and put as much instances as he wants of different curves to create different kinds of hairstyles. So that was our simple solution to create hair that we didn't need to hassle with caches and simulation data and to load those caches and unload them in render time. And the way this system works is we have the polygon mesh, and that polygon mesh is connected to the node. And the node here is called freckles. And throughout that node, you can connect different textures into different attributes and control the count, the inclination, rotation, scale, how the randomization of the curves is working on the surface. And those curves, they are connected to the shape, and if the shape changes, the curves change their normals and their direction based on the modified shape of the mesh that is connected to it. Then that data goes into the normal instancer of the Maya particle system, and that is rendered as hairs in the R-node renderer. The last thing I will talk about is about my research project, and this is a bit confusing or hard to explain. I will try to do it my best. So I'm trying to do research about real-time graphics, and I'm trying to use the graphics card and the new modern graphics card capability of calculation to try and generate procedural polygons and meshes on the graphics card and to see how much you can really generate just using the graphics card and how fast it can do that. So usually what you hear about graphics cards is people doing ray tracing and doing shading and real-time lighting and shading on the graphics card. And what I'm trying to find out is how much geometry you can create on the graphics card. How much things that if you take just one point, one vertex from the computer and send it to the graphics card, how much data can you generate with that point? So you don't need to pass much data between the computer and the graphics card. You're just generating everything on the graphics card. And how much can you really do there? And how much control can you do to create a node-based system that can give the user the ability to create geometry that is created only in real time on the graphics card. So that's my challenge, it's what I'm trying to achieve. And that's all from me now. And now I'm going to give you over to Tim. And if anybody wants to have any questions or wants to see other stuff that I've created, please, you're more than welcome to go into my website. And there's lots of more stuff that I did there. And I'll be really, really happy to hear your feedback. Thanks.
My name is Tim Wagner. I'm a pipeline and lighting and shading TD. And yeah, let's see what I've done. I'm basically doing lots of pipeline programming. I, for example, will talk about lighting and shading on the FMX trailer, as well as the Kugeltiere, the latest spot. And I'm going to be talking about some GPU programming, which I attempted, and a little bit about rigging. I have a background as a rigger and 3D artist, basically. So, yeah, I was basically responsible for the pipeline of the rugby bugs. And so I wanted to have everything organized, and I basically wanted to create a fully assetized and referenced pipeline with for example, the philosophy of workspaces for each department. So an animator would only have the information that he needs, or a lighter and shader would only have the information that he needs, and keep everything clean and manage the interfaces as good as possible. And I backed that up basically with an extensive script toolset, which you see here. And here's our pipeline diagram. Yeah, basically I wanted to have non-destructive lighting scenes. So that would we would combine our assets in the lighting and shading scene for a shot, and each asset, like you will see here, was a separate task for an artist, like an hair artist. Animator would put out an alembic cache, and the shading artist would do a shading asset. We'd combine them in our scene by the scripted toolset, and so they basically the combination is a local edit, and each artist could iterate and refine his contribution as long as they remain the interfaces, and that worked pretty well. And another thing I did was basically one traditionally delicate issue is like render, re, and deconstruction. We used V-Ray. V-Ray offers some standards like render elements, which are AOVs basically. And one big part of our pipeline was to standardize what lighters and shaders were putting out to comp, and what comp would rebuild. And so basically the scripts would ensure we'd have a linear workflow, and we would basically you could put any lighting artist at the current job. With the push of a button, he would set up the correct render elements and could render. And the comp artist would always get the same output. And what you see here is basically each light contribution, data contributions, frame buffer contributions like reflection, refraction, and that was consistent. So compas knew what they were getting. They would grade on the correct elements, like not have a combined light and diffuse color, but only grade on light. And yeah, that worked pretty well. I also did look development for the crystal and the FMX logo, and what you see here basically, for example, on the purple crystal, I really wanted to use subsurface scattering. I wanted to achieve a rich glow from the inside, so that actually are animated lights inside the geometry that trace through the volume, and that's true for all of these crystals. But yeah, in the end, that was a horrible setup. It was really large and uncontrollable. So we changed that, and it became, it basically became a refractive material with animated layers of fog inside. And that was how the logo was rendered as well. And what you see here, there is no comp lying on top. It was that was basically the beauty, and that was much more controllable and easier to process later on. So then I did all the rigging for the characters. Basically, they were done with auto riggers for about 70%. Basically, we had all the rigs, or like 70% of the rigs done before we even had the models, because I did that up front. We agreed on some standards, how the modelers would model, and so I was able to do 70% with an auto rigger up front. I created some plugins, most notably probably a roll deformer, which I will show later on. Here you see an animation GUI that was done with PyQt for the crystal, so you could control the pick all the several pieces of the crystal separately. And here's a little overview. This first will show the rolling deformer plugin. So you would just set keyframes on the translation and it would automatically roll. And it also will respect the radius automatically. That basically was a request of our animators. They wanted to have as much automated and secondary motion as possible for free. Here you see the cocoon that was fractured with Houdini, and then there was a linear auto rigger running on top to rig it. Yeah, and that's basically made the rotation a lot easier. Here you see the auto rigger in action. That's basically, yeah, no, the frog, it was a little bit more work. like the eyes and stuff that could not be automated, but yeah, here you see the secondaries again. So what I did afterwards, after a lot of shot work, wanted to spend some time programming, and since I'm interested in GPU parallelism, I wanted to do something with CUDA. And so I did a cloth solver, which is, I think the Verlet cloth solver approach comes from game engines, actually. It's based on iteration, and so I thought it's a good idea, if it's based on iteration, to do it on the GPU. Here you see it in action. It's basically the green flickering outlines here are basically attribute data. So you hear it. I think it shows you the change, relative change. You see where it's moving the most. You can change interactively between CPU computation with OpenMP, which works really well, or GPU computation. You can also stress it very much, and you will see how it behaves then. Here I do it basically to show you that the red shows the area with the most error while solving. And yeah, you have constraints. You can turn on and off. And yeah, that was basically, yeah, here you see it when solved with OpenMP, it parallelizes pretty well. Then basically my paper sketch project is I'm trying to implement OpenColor.io as Houdini COP2 nodes. Houdini has its own compositing network, and OpenColor.io is basically, it unifies the color management. You know it probably from Nuke. And so yeah, I'm basically trying to bring that to Houdini, and so probably effects artists can grade their backdrops, for example, in a consistent way across their pipeline. And what you see here, basically, it's a Ferrari that was modeled in Maya and rendered in Mantra, and I show it in my own little tool which is a Q tool. It can load images and grade using OpenColor.io. And then on the right, a little low, you see the same thing. OpenColor.io nodes I implemented test-wise within Maya shading networks. So yeah, it's basically grading samples instead of pixels there, which is probably not how OpenColor.io was meant, but I encapsulated the wrapping libraries that I did, and I'm hoping to use the same libraries in Houdini. So then another thing I did to basically get more familiar with Python and see how Python works under the hood is I was doing a wrapper of the Maya C++ API with Boost Python, my own wrapper. And who of you here is familiar with PyML? So what PyML basically is, it gives you nodes for your Maya scripting. So similar to Who nodes, probably. And it does that by wrapping the Maya commands, wrapping mel and the Python API. So that it's an API hybridization approach, and it stays inside Python. It wraps Python, and so what I was basically just trying to do was to wrap the C++ API directly. And yeah, you get your own node types, CPPy nodes, as I have called them. And yeah, that's basically, if you are renaming 40,000 nodes at once, it takes 1.3 seconds instead of 8.6 seconds. So it's you can figure out a test, and it is faster. But yeah, basically it was just a test, and it worked pretty well. And so what you can do actually basically is another nice thing when you do that, you bypass mel completely. You can have your own C++ code running inside Maya without the Maya plugin system or Mel at all. So it's quite nice. Then I did lighting and shading on the Kugeltiere, which was a pretty nice thing as well. It was done with V-Ray. Here you see a little example of the passes that we spit out. And another thing that I tried on this show basically was to to play with the EXR metadata that you can load information into. And so basically I was trying to recreate the 3D scene in Nuke from the metadata and completely from the metadata. So the comp that you see here on the left, it is automatically created at the click of a button. You get the alembic meshes back. You get the lighting probably mapped because Nuke doesn't know the V-Ray lights, for example, or probably not Arnold lights. You have to map them. And yeah, and on the left you can see the 2D render reconstruction that was done before that for the rugby bucks. And so it's nice for compositors. They have their 3D scene and they can place cards. They know where to place them. And yeah. So one thing I want to mention, there is a talk from fellow students that's organized. They organized it, and it's on Friday, basically, and they talk about the current situation of the CG industry from an artist point of view and from a student point of view. I'm going to be there. It's Friday, 25th, Raum Karlsruhe from 4 to 6 p.m. And that's from me. You can visit my website if you want. And thanks a lot.
Thank you for this great insight into your productions. So, any questions among the audience? I'm sure there's one. Oh, all the way back. Larry.
Yes, and I have a question for Yafes, the first speaker. Congratulations on working on an application to address the issue of getting data on set to everyone that's working in all the departments. My question to you is, now that all of these experts in these departments have this information, how are you managing their feedback?
So what I want to do is an annotation system. So everyone who has this device, he can do some annotation directly on the image. So other departments will get a notification. So this will be the approach to get different departments connected on set. So like in PDF files where you just scribble things, you can do the same in this tool as well.
More questions? No? Well, if you look next to you on the seat, there's probably some cards here which have additional information about the technical director course. I'll be here to answer your questions. And let's thank the speakers one more time.